I'm sitting here sweating this morning, having a cup of hot tea while it's 78 degrees inside, which is the normal temperature of the house. And outside, it is probably 91 to 93 degrees. And I'm thinking about environmental conditions. Now, we know there is a solar minimum coming along. We know the temperature of the climate and the planet is changing constantly and all the time. It is going to be hotter. It's going to be a wet, cold winter or a hot, dry summer. We're going to have more extremes. So let me share with you a carbon farming method that actually helps you build microclimates that give you maximum growth with minimum inputs. I'm Justin Hitt with Prosperity Homestead. Now, my yard looks different than other yards. I live in an urban space. I allow grass to grow about knee-high to waist-high, depending on what the season is. I am cutting the grass before it goes to seed, but I'm primarily growing the grass for carbon. Now, here's what's very important. Your garden space, the soils need carbon trapped in the soil in order to feed microbiology, that soil food web, to create nutritious and nutritionally available soil. Now, this is very important. If you just got dirt in your garden, you ain't growing anything. And if you're just doing a compost pile, you're not optimizing the billions of microbes that are available to you to work on your behalf to get your gardens going. Now, I use a specific type of no-till bed system where I create permanent raised beds. I like to play a little game. It's called Worm Bingo. We go out in the yard, and you can basically point to a spot, and I will put something in the ground and move away the soil, and we'll find at least one healthy earthworm. Now, this carbon farming method creates that soil biology, the earthworms, the microbes, the beneficial bacteria, beneficial fungi. All these things are breaking down soil using a simple method that you can follow at home. Now, if you're really interested in this, at the end of the program, I'll share with you how you can get a small little chart that shows the path that I'll describe to you right now. If you'll get out a piece of paper and a pen, you'll notice that there is a process of taking brush, plant material, and other biomass and processing it through a means of composting. Now, you can have a compost pile, you can compost in place through chop and drop, or you can compost through a variety of other ways. But what I do here is a little bit different in actually transforming woody material, mulch, and plant material into a biologically active environment. That's the permanent no-till raised bed, so that we get maximum growth of vegetables, biomass. Again, we're using biomass to grow biomass because we want to build density. This tall grass that I allow to grow is only because it's within the first year of the growth. The density of the grass, if you were to draw a square on the ground and count the number of stalks of grass in that square, and this is how you survey this kind of thing, the density would be low. We'd be at under 50% density of grass type materials. Now, if you draw a square in my yard and you 1 foot by 1 foot square and you started inventorying that, you would find 3 to 4 different types of grass. You would find legumes like or nitrogen fixing plants like clover or alfalfa. But that, even though it has a large number of plants, it would still be within the first year, especially the first 6 months, of a density of under 50%. Now, we want that density above 50% before we cut the grass low, and that's a big mistake people make with their lawns. We talk about that in year-round green lawn. But the challenge here is under 50%, that cubic foot becomes less volume. Now, I'm going to back up a little bit here because remember, we are carbon farming. We're taking atmospheric carbon, trapping it in plants and the root systems of plants. And so for every square foot that you have, so you don't have to have a big giant field for this. You don't have to have a giant yard for this. You can do this in your garden with the vertical space that's available to you. But what we're doing is we're taking atmospheric carbon, trapping it into the plants and to the root systems of these plants, and we're trying to get the maximum density. And this is very important because if you have a 1 square foot and you're going up 1 foot, that's 1 cubic foot. If your grass is only growing, or your biomass material, which could be sun hemp, could be sunflowers, and by the way, you can even do this with wildflowers and have beautiful wildflower beds that just explode with color and shapes and are beneficial to insects. But yet we're growing biomass vertically with a high density cover crop, and we're able to then turn that into compost for top dressing. And then in the case of woody materials, and this could be in an urban space, it could be tree trimmings, it could be your shrubs and bushes being trimmed. We're even turning that brush into soil material, and we'll go over that process here. But you really have three processes. One, it is wood chips to soil, and we do this in our paths. Okay, so we're taking waste material from tree service companies and we're turning it into wood-chipped paths that reduce the amount of moisture in the garden. They actually soak in the water rather than having surface water that can splash up on your plants and cause problems. It gives the humans ready access on contoured trailed paths covered in wood chips. It could be pouring down rain outside. You can walk through your garden and not see an ounce of mud. And these paths are deep. So when we talk about maximum square footage or volume, our path is on contour. It has a certain amount of surface area, which catches a certain amount of water. That water is then feeding the biology of the wood chips, which are actually in deep trenched beds. Now, my beds are about, there's going to be a cubic foot for every linear foot on the surface. Now, if I go over these terms a little fast, you can always contact us and ask your questions, but this is what's important to understand. We're taking large volumes of wood chips, turning them into paths and access, and over time, these break down into additional soil. So this is our fungal path in the garden space. Next, it is the brush. We take brush and woody material from all of our neighbors who very often just lay this out on the road and ask the city to come pick it up. I actually pick up these materials, strip the poles out of them, so that would be any straight long pieces. They're about the size of my wrist or larger. I use those poles in the garden to support vegetables, or we cut those up into small little logs, and we might even have a little campfire. But it's how we burn these materials that creates for us charcoal. This is what we talk about when we talk about the Terra Perda, which is how much the Amazon. So the Amazon is a man-made structure. It was produced by how the people who live there planted, processed waste materials, and ultimately were stewards of the space. Now, you remove the people and the plants keep growing. It was a sustainable system. Well, that's exactly what we're doing here at Prosperity Homestead. We take the neighbor's brush. We strip off all the fine materials, and we mound the brush so it dries out. The mounded brush either remains in a mound as bird habitat and eventually rots down like the wood chips would, but the rest of it is cut up into little small 6-inch long sections and burned in a special way using a retort kiln or a barrel designed for this purpose, where we process that into actual charcoal. The charcoal is then crushed and then put into the compost pile. Now, the reason we put the charcoal in the compost pile is because we want to inoculate that charcoal. See, charcoal has immense amount of surface area when processed the right way. I'm not talking about campfire charcoal. In fact, this method has near zero ash. It has almost 100% carbon charcoal. We've burned off all the volatile gases. We burned off all of the other materials. And in fact, the volume that we put in, we get 80 to 90% of that in volume of charcoal when the process is done. Now, if you're interested in the process of making biochar, contact us and we'll answer any questions that you have. That is the second path, turning brush into charcoal and that charcoal going into compost. Now, charcoal is 100% carbon, and so you can't quite compost carbon. It just doesn't, it's a natural material. It doesn't break down any more than that. So we use our third channel, which is plant material That could be waste plants out of the garden into season. We chop and drop the plants, and we take some of that volume of the chop and drop and we put it in the compost pile. It could be vegetable scraps from the home. It could be grass clippings, leaves. We've gotten waste material from the neighbors, so fine brush. That we've basically, you mound the brush up, stomp on it a little bit, take the woody material away, and everything that's left behind then gets rolled into the compost pile. We've brought animal manures on site. We have a couple friends with farms, and they get these huge piles of animal manure. And after the manure is aged about a year or so, I'll go get 2 or 3 cubic yards of it, blend it in with my compost piles to add some nutrition and to add additional fiber and carbon into our mix. We don't use any outside fertilizer except when we're establishing a new area, because we've had a large amount of excavation work and what was left behind was clay. We did use Milgonite and some fertilizers that the neighbors had in their shed and they were just getting rid of, and also lime to get the pH right of the soil. But ultimately what we're doing here is quickly establishing our woody plants, our vegetative plants such as grasses, clover, sun hemp, sunflowers, corn, other things that grow volume. Because here's the key to what we're talking about here. You don't need a big space because your square foot can go vertical from 5 to 6 feet. So if every square foot of your yard is becoming 6 cubic feet of carbon, you're now bringing that much carbon out of the atmosphere, turning it into fertile soil, applying it to permanent raised beds where we're feeding soil biology such as worms, microbes, fungi, even bacteria that are then breaking down the materials and making nutrients more readily available. Now we use deep root plants as well, like comfrey. Comfrey gives us the mineral accumulation that comes out of the ground. Now, there's cases where I have thistle on the property, and I know thistle's invasive, but it's also a highly valuable medical plant. So what I'll do is allow it to grow before it blossoms. We'll actually cut the blossoms off and make a wonderful tea that's good for your liver, good for your system. Now, I'm not a doctor. You work with our herbalist about the plants that are in your yard that are most appropriate for your health interests. Now, I take the rest of the thistle and I chop it all up, put it into the compost pile, because thistle is an accumulator of copper, magnesium, and a variety of other minerals that provide for the supplements that most people are chasing the store to buy. I don't have to supplement the soil. I don't have to buy in materials. And in fact, we're producing 3 to 4 cubic yards of compost every year. Now, there are some logistics that we talk about in the carbon farming method, because you don't want to be hauling around bulk materials. We do buy in wheat straw because the local farm I buy it from produces a volume of wheat straw at a price that I could not match with my physical labor or even the physical labor of my kids. We do buy in the manures periodically. I give a tax-deductible donation to a nonprofit farm in order to haul off their manure, which is clean, and it comes from a variety of sources. It includes camel, alpaca, horse. It's got like everything in it, and it's been aged for about a year, so it's a good source. Now, I've also helped people source horse manure from a local equestrian center. All of these outside sourcing are actually helping a local person or a local organization solve a problem. So when we source material from the equestrian center, we're helping a school reduce their costs. When I donate to a nonprofit, the 15 or 20 minutes it takes to load up my trailer is nothing compared to the value that they can create by using my donation and freeing up space for additional manures. When I bring in straw, for example, I'm supporting a local farm who's using contour farming and natural principles to grow large volumes of wheat, cover crop, and tobacco. Now, this gives me the opportunity to take in some inputs, which are probably not necessary, but it allows me to supercharge this carbon farming system. We're taking huge volumes of carbon out of the atmosphere. We're turning it into charcoal, and we're turning it into biomass. And I'm also helping my neighbors, by the way, when we get 8 to 10 cubic yards of their leaf material that I will then compost over the year. We get their grass clippings, their tree trimmings, everything, and the opportunity to advocate a no chemical landscaping method. So most of my neighbors, the only thing they put on their yard is lime and a small amount of fertilizer, which has been organic fertilizer, because for some reason they still want super green lawns. They're quite confused why my yard is super green all the time and I don't add any fertilizer to the yard. Now, we do add lime because we're managing soil pH levels, but the secret is in this carbon farming method. We actually will blend grasses, multiple grasses. So if we're establishing a new area in grass, being in an urban space, I put in a pasture blend of grass with clover and alfalfa. The clover and alfalfa fix nitrogen from the atmosphere, feed the grasses, and now I have rapid growth of biomass. As long as we cut the grass before it goes to seed, I have conditions where I have straw that can go directly on the garden beds. I also have straw that can go directly into compost and only need 1 or 2 hot cycles in order to make it soil. The other inputs that are coming from on the property include all of the tree trimmings around the house. When you're not tidying up around the house and you've got idle beds growing out, you can chop this material down. You can either chop and drop it in place, or you can otherwise take it over to a compost pile and process. Now, we've got 3 or 4 compost piles here because I don't want to carry those materials too far. Because when you have, for every 1 square foot, now think about this. For every 1,000 square feet of surface area, 1 inch of rain is 600 gallons. It adds up quick. And so if I have 1 square foot of grass material and it is growing 6 feet tall, 3 feet tall, because a tree could be 6 feet tall, and grass could be 3 feet tall before it's cut. And by the way, this looks great. It's super green grass. It waves with the wind. It actually looks great. It can be confusing to people, but if you cut paths around it, it looks like it was meant to be, and especially if you're using wildflowers. But here's my point. That 1 square foot of ground at 6 foot tall is 6 cubic feet of carbon materials. Now, at 50% density, it's less than the material I like. I like to stay at higher than 50% density. But if you have 1,000 square foot yard and you're growing 3 foot tall in this area, maybe it's a little square area where you're growing sun hemp and sunflowers. The sun hemp produces a small yellow flower, and your sunflower is going to produce a big yellow flower as well, and it looks really good. It looks just like a big fireworks display. If you do that, 1,000 square foot, 3 feet tall. Now, I know there's sunflowers out there that grow 6 and 8 feet tall, but at 3 feet tall, that is 3,000 cubic. This is very important. 3,000 cubic feet of biomass. And you can see how it can feed composting systems. It can feed volumes of bird habitat. That becomes like an apartment building for birds. They can fly in there and have safety and shelter. And then when the seeds of the sunflowers drop. But again, if you transform this into your growth area, you could have corn and clover doing the same thing. Red clover will grow maybe about 1.5 feet tall. Your corn will grow 4 or 5 feet tall. Average that all out, gives you about a 3-foot block of biomass. At the end of the season, you chop and drop that. You take half of the biomass, add it to a compost pile. The other half you leave on the bed to prepare for the next season. You are now feeding the garden bed, feeding the microbes and soil biology. You're creating an area of composting where you can actually inoculate and just really build that fertility. Add your charcoal, crushed up, powderized charcoal. That charcoal then is inoculated with the microbes and then put on as a top dressing for your no-till, no-dig, permanent raised beds, and the process continues. In fact, you'll be creating more carbon locked up in the soil than you'll produce. In fact, our property is near zero. I did mention it's 78 degrees upstairs. It's like 65 degrees downstairs, but One of the things that we're doing at Prosperity Homestead is we're quickly moving towards carbon neutral. We're moving towards carbon neutral because I've got 2 acres of biomass growing in an urban space. And it doesn't look bad, folks. In fact, we've probably got 3 times the house square footage in just solid biomass. Now, again, in an urban space, you can make this look nice. You can use paths, you can use designated raised beds, you can use grow out areas, you can use basins. You can do a lot of things to make this look nice. Our primary objective is to reduce erosion and build soil. So we are cutting this grass in such a way that we're getting deep roots in the system. Now, we don't have time to go over it right now, but there are ways to cut this biomass, mound the biomass in place, but also be stimulating root systems. And that means there's times to mound the biomass, there's times to remove the biomass, and there's times that if you've got chickens and other things, that this biomass becomes inputs to other systems. But ultimately, you can have a biomass that could be pole beans. It could be gourds and the vines from gourds. It doesn't have to be grass. But what we're doing here is we're going for volume. We're extracting from the atmosphere carbon. We're reducing greenhouse gases. We can go into another episode that actually mounded brush and grass material that's not properly composted is actually exhausting methane. We talk about the making of charcoal using a retort kiln or a specially designed, and by the way, this isn't difficult, but making the biomass is actually carbon negative. We're burning off volatile gases at such extreme temperatures that we're not producing anything but carbon dioxide into the atmosphere. That's completely different than when people burn leaves or when people burn brush on the side of the road. These are systems that are sustainable. These are systems that can be done in urban space. If you have questions about what I've shared today, and you have questions about the transformative nature, because I didn't even get a chance to go into how this creates shade banks and microclimates and other factors that actually reduce the temperatures of your property. But if you've got questions or anything else, visit me at www.prosperityhomestead.org. I'm Justin Hitt with Prosperity Homestead, helping you manage your small farm, homestead, or estate. And this was a simple description, kind of high level, of our carbon farming method that takes your land, extracts carbon from the atmosphere, and turns it into fertility and prosperity. Thanks for listening.